So now we've talked about interquartile range. We saw from in our previous page that interquartile range is the value of Q3 minus the value of Q1, which if it's been a while since you saw that video or you kind of didn't understand it to begin with, we throw a visual of our distribution like a dot plot or a histogram, the minimum value being on the left, the maximum being on the right. And then we split the data into 4 pieces, so equally 4 groups of data. Quartile 1 is the smallest quartile, the smallest values. Q1 is the value that ends quartile 1, so whatever that x value is there. And then quartile 2, one of the examples we saw on the previous page, quartile 2 was very narrow. So Q2 represents that value where the quartile 2 ends. And then quartile 3 ends somewhere. Kind of depends on the example, of course. Q3 is the ending point, the highest value in quartile 3. And then, of course, quartile 4 ends here at the maximum point. So it's the interquartile range you calculate by taking the end value, Q3, as the end value of quartile 3. The highest, I guess I should say. High value of quartile 3, and then quartile 1 is similar, but it's the highest value of quartile 1. Value of quartile 1. Yeah, the very rightmost, I guess you could think of it as. So we'll look at a way now to calculate what an outlier is. Is a value actually an outlier or not? That's what we're going to figure out here. So they really nail it down here with the kind of like a formula. A value on your dot plot or your histogram is an outlier when the value is greater than Q3, which we talked about over here. Q3 is the largest, highest point in the quartile 3. Q3 multiplied, or sorry, if the value is greater than Q3 plus 1.5 times the interquartile range. So we're just assuming you've already calculated the interquartile range using this formula. It's going to give you some number value. Or if that's not the case, if the value is less than quartile 1, the ending value of quartile 1, minus 1.5 times the interquartile range, which is just some number, like we said. So that I definitely write that down on a note card or in your notes. That's very important. And that seems like just a lot of writing. But so for the data set down here in this example, we see that probably the first thing you would want to do when you're trying to calculate this is, of course, they found all the data values. They put them on a dot plot. But once you do that, then try to break your data values, divide it by 4, and create quartiles. If someone hasn't already done that for you, and then I would calculate the interquartile range. So that would be Q3 minus Q1. And now that we have this all nice down here, I see Q1 down here has how many? 6 values above it, but it looks like it's at 15. So Q1 is 15. And then we're subtracting that from Q3, which is here. I see they labeled it at 18. Let's see. Yeah, 18. So 18 has an owie. Sorry about that. That was my daughter. She got an owie and she thought she needs to tell everybody about it. Anyway, so the quartile 3 ends at 18. So they wrote that here, and then quartile 1 ended at 15. So here we calculate 18 minus 15. The interquartile range must be 3. Okay. And then to calculate whether a number is an outlier or not, we're talking about taking 1.5 times the interquartile range and adding it or subtracting it from something. So I might then calculate what's 1.5 times the interquartile range. So in other words, 1.5 in this case times 3. So we get 4.5. 1.5 times 3 is 4.5. Okay. So now we'll calculate to see if a value, as it shows on that box up there, this is the kind of the benchmark. The value is greater than, I don't know if you remember that symbol. You can just write the word greater than, but if you want greater than Q3 plus 1.5 interquartile range. So quartile 3 ended at 18. So this is 18 plus, we already calculated 1.5 times the interquartile range, but we could do it again. 1.5 times 3 was the interquartile range. So 18 plus 4.5. So any value greater than 18 plus 4.5 is 22.5. So if we were to look at the dot plot and we see a value greater than 22.5, that's an outlier. But the other way also is, sorry, you can rewind that if you didn't get that, I'm sorry. In order to move the screen, I have to stop all the writing. Anyway, also Q1 minus, 1.5 times interquartile range is another way. If there's a value less than that, that means it's an outlier on the left side. The first one that we calculated was an outlier on the right side. So I think above we said the value greater than 22.5 would be an outlier. Now we're going to see outliers that are low. So what a low outlier look like? Q1 was 15, we saw that earlier, minus, and this we already calculated, 1.5 times 3 is 4.5. 15 minus 4.5 is 11.5. So we said any values that are greater than 22.5 and any value less than 11.5. Those are outliers. So now we finally have a technical definition of outliers. So as you see here, they have, so it looks like here they've sectioned it off. Anything less than 11.5, they have this green bar here. Notice 1.5 away from the interquartile range ends there, and then above 22.5 they have marked off here. And there are a few values. Let's see, right here there are 4 values in that are larger than 22.5, and there was only one though that was less than 11.5. So there are 5 values that are outliers in this case. So here to summarize, a range measures the variability of a distribution by looking at the that interval covered by all the data. The interquartile range measures the variability of a distribution by giving us the interval covered by the middle 50% of the data. The five number summary of a distribution consists of the minimum, quartile 1, median, which is where Q2 ends, and then quartile 3, and then the maximum, which is where Q4 ends. The interquartile range is the measure of spread we should use when using the median to measure center. When using the median in an interquartile range, an interquartile range to measure center and spread, a data point is considered an outlier if it satisfies one of the following conditions. So these, like I said before, these would be something to write down. If a data value is more than 1.5 interquartile ranges greater than Q3, i.e. the value is greater than, so you might want to write that as a little formula, Q3 plus 1.5 IQR. The data value is more than 1.5 IQRs less than Q1, i.e. the value is less than Q1 minus 1.5. So now we have an actual way to calculate whether something's an outlier or not. That is if we use median to measure the center.